All right, now we're going to switch gears a little bit, and we're going to talk about the most recent enhancement that we made, or one of the most recent enhancements that we made to the programmability framework in iOS XR that gives us a new alternative to do network automation on an infrastructure that is using iOS XR devices. And this new alternative is called GNMI, gRPC Network Management Interface. And I'm going to start off, so bear with me in this slide because I'm going to kind of give you a very abstract, very high-level definition. And then what I'm going to do is kind of put it in the context of the whole programmability in XR, and hopefully will make sense what is it that I'm talking about here. So GNMI stands for gRPC Network Management Interface. It's a management, you can think of it as a management protocol defined by the OpenConfig consortium or group. How many people here have heard about OpenConfig? Okay, that's good. So we have enough people. One of the important characteristics of GNMI, and it's something that you need to take away, is the fact that it's a protocol that allows you to do both configuration management and telemetry on the device. And I'm going to talk more about this, and the follow-up presentation by Mike actually goes into the details of telemetry within the context of GNMI. The importance of this being an integrated solution for both configuration management and telemetry stems from the fact that gRPC accommodates or provides efficient data streaming, which becomes very important for the telemetry aspects. If I want to program a networking device to stream real-time to a collector metrics and statistics about the operational state of the device, I want that information to be very efficient, that streaming of information to be very, very efficient. So GNMI is based on the Google RPC technology, and it has rich tooling. So I'm kind of giving right now a very abstract definition of what GNMI is. And what I'm going to do next is kind of put it in the context of the programmability options that we have in iOS XR and how GNMI fits into that. So the first thing, I don't know, some of you guys, I think we did a tech field in the past where we talked about the two different frameworks of programmability that we have for XR. I want to kind of give a very brief refresh of that. On iOS XR devices today, you have two types of programmability or programmatic access that you can do to manage and operate a device. The first one is what we call model-driven programmability. So basically, from an app or a controller that is typically off-box, you're trying to manipulate the device, operate the device, going through the management plane. Okay? You can think of it as kind of the traditional network management or a new approach to the traditional network management that was typically based on SNMP, on syslogs, on CLI. We're going to see that all that framework is being rewritten, and GNMI is going to fit into that new framework. The other approach to programmability is the service level API, in which you don't go through a management plane, but you're programming, for instance, the control plane, routing entries on the device. So GNMI fits within this first framework. And let me actually zoom into that framework. So in that framework, you're trying to automate a device, automate the network, right? Using some kind of controller and orchestrator, and you have an interface in the middle to interface with that device, okay? What you're looking to do is to do some type of closed loop automation in which you can manipulate the configuration of that device, and you're able to get in real time telemetry data from the device so you know what's the status of the device. It can be a closed loop automation, can be one particular use case is you make a configuration change on the device and you want to validate real time that the device achieved the operational state that you intended with the configuration. Another closed loop automation can be, for instance, telemetry sending constantly statistics about the device, for instance, interface counters, and you trying to detect here some kind of anomaly and react to that anomaly, right? And reconfigure the device somehow, okay? So we want to be able to do this closed loop automation, but we want to do it in a more modern approach, right? We don't want to be doing that with the traditional old-style syslog, CLI, SNMP. And that's a framework that we use today in XR that's completely based on data models that we see in the bottom part, data models that define everything that can be configured on the box, everything that can be monitored on the box. And there's some kind of protocol encoding and transport that can be used by this controller to interact with the device And the controller orchestrator is going to have some automation applications that are going to be built with some SDK, right? And we're going to talk about that. Let me actually cross here for a sec so I can talk about this middle layer, right? Which corresponds to the protocol, the encoding, and the transport that is used for the controller or the orchestrator or the network management system to interact with the device. There are two basic options that you have in iOS XR. You can use NetConf, which uses XML as the encoding of the data, whether you're reconfiguring the device or whether you're reading some operational data from the device. That connection typically happens over an SSH or TCP. Or the other approach is Google RPCs, and this is where GNMI fits in. So GNMI gives an alternative to do this closed loop automation, right? And it gives you, in the same connection, the ability to do the configuration piece and the telemetry piece, okay? In terms of encoding, we're gonna see the configuration typically can be pushed in JSON format, and the telemetry data goes on encoding type Google Protocol buffers. How many people here have heard about Google Protocol buffers? Okay. So it's basically an encoding, in very simple terms, encoding that allows you to have binary transfer of data in a very compact and efficient way, okay? So when you think that if you wanna be able to stream in real time statistics about the device at a given frequency, you want that transfer to be very efficient. You don't want to do that transfer of telemetry data in JSON or text-based format because it will be CPU intensive to process. So with GNMI and gRPC, you have the option of having that telemetry, very efficient in binary format, and it's still being able to reconfigure the device, make changes to the device in JSON format. And all that is done over a single HTTP connection. So you have a single management connection to the device. On that connection, this is actually HTTP version 2, right, which is capable of streaming and binary transfer. And on that single communication channel, management channel, you're able to do both the configuration of the device and the telemetry piece. So basically, this closed loop can be implemented with a single protocol, with a single communication channel. That's kind of the important characteristic of GNMI. Where does GNMI fit within the story of OpenConfig? OpenConfig group as a consortium of service providers that started defining data models. They wanted to define vendor-neutral configuration for BGP, vendor-neutral configuration for interfaces, et cetera, et cetera. So that's the initial work that they pursued. At some point, they decided that they wanted to have their own management protocol. Okay, and that's what GNMI is. GNMI gives the alternative of having a separate network management protocol. Doesn't mean that you have to use, or you can only use GNMI with OpenConfig data models. You can potentially use with vendor-specific data models. In the same way that OpenConfig data models can be used with NetConf, for instance, or with RESTConf. Okay? There's no dependency there. There are other components that are coming in that ecosystem that are kind of outside of the scope of this presentation, but I just mentioned it here for completeness. There's GNOI and there's gRPC, which are other components of programmability that are being done within the context of OpenConfig. So what is it that the protocol can do? Actually, it's very simple. It's 4 sets of operations. Remember, this is GNMI is based on gRPC, which is a basic client-server framework. So you have a client that is always going to send requests to a server, and the server is going to reply. The client is some kind of off-box, typically off-box software that resides on a controller or an orchestrator. The server is going to be the router, the routing device. Okay? So the client is going to be sending some requests to the router, and is going to get some responses. So what are the requests that it can send? It can send a basic request of asking for the capabilities of the router, because you have some automation software that needs to connect to a device, and it wants to know what kind of data models, what kind of version, what kind of extensions that device supports. So it's a basic discovery mechanism for an off-box software be able to connect to the box, a box that is going to manage, and learn about that, the details of that box. You have 2 basic operations, a get and a set. The get allows you to retrieve either configuration, read configuration from the box, or read operational data from the box. Maybe I want to read what's the current BGP configuration. Maybe I want to read what's the current state of an interface. Okay? The fourth and very important operation of GNMI is the subscribe operation, or the subscribe RPC. The subscribe allows a client to indicate to the router, I'm interested in being streamed some operational data. There's a lot of options that this subscribe operation has. You can, for instance, indicate, the client can indicate, I want to get interface counters every 30 seconds. And from that point on, the router will start every 30 seconds sending. Or you can say, you know what, I don't want to get the interface state every 30 seconds. I want to get interface counters every 30 seconds, but I only want to be notified of changes in interface state when the state actually changes. Don't tell me every 30 seconds what's the state of the interface. Tell me if the interface changes or not, okay? So again, capabilities allows that client software to discover capabilities of the device. Get is going to read either configuration from the box or read operational data. Set is going to reconfigure. You can only write or delete configuration. And subscribe is the mechanism to start streaming data back to a collector, okay? So these two are more related to configuration management, this one to the telemetry piece. Okay? Any questions on this so far? Okay, let me give you in a very briefly, because I think Mike is also going to give more details on this. When it comes to the implementation of the GNMI specifications in iOS XR, we released it in 6.5.1, which is last summer. Okay, in iOS XR, I think also in iOS XE, in some of the iOS XE devices is also supported. So we support the capabilities, we support all the operations capabilities, set, get, and subscribe. When it comes to set and get, the configuration data or the operational data that is read, it's going to be read in JSON format. We give you an alternative. If you want to push configuration as ASCII, there's an option to push actually CLI. But if you're really doing any modern network management and automation, you shouldn't be trying to automate anything with CLI. You should actually do it, obviously, with structured data, with the JSON format. We support the subscribe RPC. A couple of maybe technical details to be aware of. When you're going to subscribe to some data, for instance, I want to get interface state sent to me periodically, you indicate in the data model is a tree, so you need to indicate the path or what is the value that you're interested in. The specifications of GNMI allow you to choose any arbitrary path. You can send a subscription with an arbitrary path, but in XR, we stream at certain points, not arbitrary. There's some predefined points in the model. So, for instance, I may be asking for, let's say, maybe a ridiculous example. I want to get the MTU, the interface stream. MTU is part of a larger bucket of data that we send, so we send you the complete bucket of data. We don't send you just a particular leaf. So maybe that's that one technical detail that needs to be, but that doesn't create any issues. It's just that if you ask data, you may get more data when you ask for. You never get less than when you ask for, I guess. Okay? So those are on a very high level, some of the details of the support that we have in XR. What we typically tell people, and one of the challenges that we see with programmability, is that we go to customers and we say, okay, the router has all these cool capabilities. And they say, okay, how do I start leveraging that stuff? I want to do automation. How can I? Okay, yeah, the device has data model. The device supports netconf, or in this case, GNMI. How do I write some automation software? So we actually came up with an SDK that is called YAN Development Kit. There is a library. We release it right now in 3 different programming languages, YDK, C++, I'm sorry, not YDK, Python, C++, and the Go language. You can install it on Mac OS, on Linux, and I have some of the details of how you can try it. And it's an SDK that already has, first of all, built-in support for the data models, built-in support for YAN. It has built-in support for protocols, management protocols, so it has built-in support for netconf, restconf, and for GNMI. As I said before, it has support for multiple, or a rich set of data models. It comes in different languages, programming languages. It has built-in data validation. So one of the challenges that someone will have if they want to try to use some of these interfaces and they did not have an SDK like this is that they have to figure out, oh, how do I write code to talk netconf to a router? Or how do I write code, oh, netconf is XML, how do I find an XML library? Or if I'm doing JSON, where do I find a JSON library? Where do I find a library? This already comes with a built-in SDK that has all the handling of JSON, XML, GNMI, netconf, all that stuff is abstracted away. And from a programming perspective, the programmer only needs to deal with a hierarchy of classes with objects that completely mirror the structure of the data models. So you can grab a developer, and that developer can work with a network engineer and start writing code without being an expert in Yang, without not needing to worry, how do I manipulate JSON or XML? All that is automatically built into the SDK. And actually I have a very brief demo when I'm showing a script, a GNMI script, where we are reading some information from the box, written in Python, very simple code. All this is open source, and the pointer in ydk.io, you can get more details on that. If someone wants to get started with building a small client, can be on your laptop, on a Linux machine, or on a Mac OS, building a small script to interact with an XR device and start manipulating the configuration, or maybe programming the router so it can start streaming some data back to you. You can install the SDK natively on Mac or Linux. We also have a sandbox in a Vagrant sandbox, and I put the pointer in there. There's also Docker containers that have a pre-installed version of the SDK in Python and the Go language. And we also have a sandbox on the Cisco dcloud. How many people here have used or heard about the demonstration cloud? So if you go to dcloud.cisco.com and you look for Yan Development Kit Sandbox, you actually get a Linux machine with 2 routers connected back to back where you can start writing some scripts and play around with those routers. So these are some of the resources. And all this is being updated or has been updated with GNMI. If someone wants to give it a try, you can use any of those resources. All right, so let me do a very quick demo. And this is actually using the setup that I just mentioned in dcloud, and what could go wrong live with a demo, right? So let me try to make maybe the font a little bit larger, because I think otherwise it's going to be difficult for people. What about 26? Does that sound about right? Okay, hopefully that's big enough. Okay. What I'm going to do, there's a data model that allows me to check what's the system time on the device. I want to see what's the uptime and how long the router has been running. This is let me show you here right now. This is a Linux machine. It's an Ubuntu box on which I have pre-installed the SDK. Oops. We want to grab this. Okay. So we have here all the installation, the Python packages that have been installed, and I wrote a very simple script that uses GNMI, and the script takes as an argument the details of the router. So let me type the address of the device. The router is listening on ports 57,400. And what this script does, using GNMI, remember one of the operations is a get. I want to get the system time, and the script just reformats the data. The data is going to come in JSON format. It's going to reformat the data to make it human readable, and it's going to give us some details of how long this router has been up. Okay? So it tells us, this script says, it kind of reformats the JSON a little bit and says the router host name is R1. This is the current system time in UTC format. It comes from the calendar of the device, and the router has been up for, I guess, 18 hours. If I run the details of this script with login, so we can see the details of the communication that is happening between this Linux machine and that XR device. We're going to see the details of the messages. Let me scroll up here very quickly. Okay, so we see here the details in the logs. There was a get sent to the router asking for the system time, and we expect that data to come back in JSON format. And we see here in the bottom part the response that we got from the router. They say, okay, you asked for the system type, and this is the data encoded in JSON format. Okay. Unfortunately, and I don't want to necessarily bore you with all the details, of Python, but here from a programming point of view, the script is very simple. What I'm doing is opening. You see here a reference to a GNMI connection, so I'm opening the GNMI connection to the router. I'm indicating here I want to get the system time, and I'm using an abstraction of GNMI. One of the things that I said the SDK has that is abstracts Yang, the protocols, and a lot of things. So I can use an abstraction that is called a CRUD service, a create, read, update, delete. So I'm saying I want to read that system time on that connection and the GNMI connection to that router. Okay? I get that object, and I call this function that basically reformats the JSON to make it human readable. And I guess without delving too much into the details of the Python, what is maybe important to understand here is that this is the function that does that conversion. That function is not really manipulating any JSON directly. That JSON string that you saw in the debugs got converted into a Python object. And all the programmer has to do is kind of access that Python object according to the structure of the data model. So there's someone that is not an expert as an expert developer, or someone that is not an expert in gRPC, that is not an expert on GNMI, that is not expert in Yang, would be fairly easy to still be able to write these clients because, again, all those details of the underlying technology are going to be hidden away from you. And actually, I have, and I'm just going to close with this, is kind of show you the same version of this script, but done with netconf for comparison. I'm assuming most of you probably are familiar with netconf as a traditional network management protocol, understand that the transfer is done in XML, just so you can contrast and
show how bad XML looks.
Yeah, so I'll make you make the judgment of which one looks nicer. That's
which one looks better.
Personal preference.
Yeah.
I'm not going to go on camera. Okay. So we see the output of the script is the same, but if we run it with the login, you see it's basically the data gets exchanged in XML and the conversion is done. If you compare the GNMI version and the netconf version of the script, you actually see that the scripts are almost identical. The only thing that you're changing is a piece of the code where you say, open the connection to the box via netconf or open the connection to the box via GNMI. Which speaks a lot about the abstraction, right? You can easily change even the protocol that you want to use, and you can focus on what is it that I want to get from the router, what's the structure of that data. I'm less concerned on, is the data JSON, is the data XML, all that stuff is handled automatically by the SDK. Any questions on that? Minimize that. So let me just close very quickly. Now that we survived the live demo, with kind of the key takeaways, okay? So I mentioned GNMI brings an alternative to network management, to a new network management interface and automation of the device. Key characteristic is going to combine configuration management and telemetry, so it has efficient streaming of binary data, and Mike is going to talk about that next. Okay, we introduced support in XR in 6.5.1 last summer, and we introduced the support in the SDK and YDK actually in December. So we have both a solution for the client side and of course the solution on the router on the server side. Any questions? Okay, that's good. So Mike will talk next about the telemetry. He's going to go into more details on the telemetry aspects of GNMI because there's obviously a lot of interest. Telemetry opens the door to a lot of analytics and interesting automation and manipulation of the network. So we're going to talk in more details about it.
I'll ask one thing, and then if he's going to talk about it,
Yes.
just let me know. So speaking of the telemetry and the closed loop and all that,
Yes.
are you going to go into, so there, obviously there's an appliance or something that's going to run somewhere, collect that telemetry and continually collect and also automate and provision, make sure I'm in desired state, right?
So we have I would say, customers that are in very wide spectrum. There are customers that, and a lot of the customers, for instance, on the web market, they say, hey, I just want to make sure that you give me a strong infrastructure on the router.
Let me do it.
And maybe even the SDK, because I have the software expertise, I can write this automation for myself. We have some customers that say, hey, I don't give me a product, give me a platform already that does the collection, the analytics, and all that stuff. I don't have 50 computer science PhDs to do this stuff. And we have customers in between. So we have commercial products. We're not going to talk in this event about the commercial products, but we have some commercial products that leverage all these interfaces and do all that closed loop. And we have some customers that say, hey, I have the expertise, just give me a rich infrastructure on the device, I'll run with it.
Okay.